So this is a homework question from last night from 1.431. All right, and then we're going to move on probably pretty quickly to tonight's lesson. So first off, I got to read the word problem and just kind of give information, find out, just relax on it. So the number of seats in each row of an auditorium increases as you go from the back, go back from the stage. The first row has 24, second row has 29, the third row has 34. If there are 35 rows, how many seats are in the auditorium? Now, right there I go, okay, they want to know how many seats are in the total auditorium. That would mean I would have to add how many rows are, how many chairs are in the first row, how many are second, how many in the third, how many in the fourth, which means I'm doing the summation of all of that, aka a series. My series formula is, do you understand why I know I'm doing a series by reading that? Yeah. And then I go, okay, my series formula is this. And the reason I think about this is only the information I need. What is going to be my n for this series? 35 is going to be my n because there's 35 rows, and I'm going from row 1 to 35. If I was only counting from row 10 to 35, my n would not be 35. Do you follow me? Okay, so since it's 1 to 35, we're good. What is my A1? Well, let's read again. The first row or front row has 24 seats. When they say that, they are saying A1 equals plus. What is AN? We don't know what that is, but it's the 35th row, right? So that means I need to know A what? And I need to know A35. They don't give that to me. This is still a question mark. But did they give me enough information to figure out how many chairs are in the 35th row? Yes. What formula do I have to use in order to find how many are in there? And so I'm going to go A1, which was 24 plus, and they didn't tell me the common difference, did they? I can look at it and figure it out, right? That's the difference between algebra 1 and algebra 2, right? They don't spoon feed everything to you, but they give you ways to find it. And then it would be 35 minus 1. Again, I'm probably not going to finish this out. I'm hoping you guys know how to do math. I mean, like 35 minus 1 is 34. You would do 34 times 5, yes? And then add 24. Do I need to do that, or can you guys do that in a calculator? So you're going to get some number. I don't care what the number is. That number is then going to go right here. You're going to add that number to 24. You're going to then times it by 35, then divide by 2. And when you do that, you should get 3,815 seats. Yeah. Go.
So it's the number 34 times 5. Is that number right there?
What?
34 times 5, whatever number that is that number?
Divided by 2. 3,815. Does that make sense? And yeah, I'm okay with not doing all the math because I want you to practice being able to do order of operations. So you should check it. If you don't get 3,815, you got some gaps we need to figure out what they are. Does that help?
You want more?
Sure.
28.
I will set that one up, Nick. That should be easier now.
Actually, 29. 29, or 30.
Huh? Yep. We didn't do 30? So we did 30. If we did 28 through 30.
That includes 30.
All right, it scares you guys away, I think, because it has a fraction in it. We can't shy away from fractions. So remember, what this means is I want the summation from when you plug a 1 in for n all the way to where you would plug a 12 in for n. So you would be plugging in 12 different numbers in for this n. If you wanted to get the whole sequence, Nick, you'd plug a 1 in, you plug a 2 in, you plug a 3 in, and each time you plug in, you'd get an output. And that would be, when you plug a 1 in, that'd be your first term. You plug a 2 in, that'd be your second. But we don't need to do that, right? Because we know a formula that says, hey, you don't need the whole sequence. All you need is the first term, the last term, how many terms there are, and then cut it in half, and you've got the summation. This formula makes it so much easier than having to have all the terms and having to add them together. Does that make sense?
Yeah.
The way I find my first term, they didn't give it to me, but they say your first term is when you plug in 1. Is that making sense, Colin? You're good so far? Okay. 1 over 2 minus 9. A half minus 9 is a negative 8.5. That would be my first term. So over here, I would have a negative 8.5. Plus, how do I find my last term? What do I do? So if I plugged in 12 for n, it would look like this. 12 over 2 minus 9. 6 minus 9, which is a negative 3, be careful. So negative 3 is my last term. Nick, you with me?
Yeah, I'm not good with fractions, so I don't know how to do that.
You just take 12 and divide it by 2. A fraction bar is a division.
How do you know if you have to put that number in parentheses? Is it always in parentheses?
I do it when it's a negative and a positive right next to each other, just to help myself remember
I
that.
realized that after I asked.
Yep, it's okay. How many term numbers were there, Nick, if I'm going from 1 to 12? And then you just do that math.
Just add them together.
You would do this
Multiply by
first,
12. Yeah.
multiply by 12, then divide by 2. Yep. Questions? Yep. Okay, I'm going to start this one. I'm going to let you try it again tonight. Because it is, and I think the setup is hard because it is worded weird. And we got to think about it logically too, okay? So it's a race car. So it's going really fast, right? And it says in the first second, it travels 34 feet. It says every second after that, it travels an additional 3.5 feet. So this is between second 0 and 1, it travels 34 feet. How many feet does it travel between second 1 and 2? We have to add 3.5 to this, and if you do that, it gets you to 37.5, yes? Now here's where I think your thinking is a little off on this. That's not how many feet it's traveled total. That's how many feet it traveled from 1 second. So it traveled 34 feet here. That was between traveling 0 to 1 second. It traveled 34. Between here and here, which is 1 to 2 seconds, it traveled 37.5 feet. From 0 to 2, how far did it travel total? Would be 71.5 feet total. How did we get that? We added those two together. Do you get what I mean? So again, we're doing a summation problem. So I need to figure out A1, I need to figure out AN, and I need to figure out how many terms there are. Then when I do that, that will tell me how, because all this, if I just kept going up by 3.5, is telling me how many feet it traveled between 2 and 3, not total. Do you get what I mean by that? So do I have A1 right now? Do I have the first term? What is the first term? That's my first term. They wanted me to see how far it travels in 52 seconds, yes? Well, if this is A1, that's 1 second, right? This is A2, that's how many traveled in 2 seconds, right? For the second. How far did it travel on the 52nd second? Do we know that yet? What formula would we have to use? So we would go A52 equals A1 plus 3.5 times. There you go. And then you can do that will find you what would go into here. You follow me? And what would be my N? Yes, 52 would be your N. So once you found this, that would go into here. Your 34 is your A1 and 52 would be your N. Boom. Now you got all your information, you can figure it out. Yes? And when you do that, you should get a total of 6,409. And again, Mr. Martin is okay with not doing all that math because I want you to go home and practice that to make sure you can get that number. That's what you should get.
So, the explicit formula helps you get the last number.
That's what it does, or any of them.
Yeah, but it's very helpful for the last number. Then
This is a series formula. Series formula adds up all the terms in a sequence.
and then isn't there one more formula?
Yes.
What is that one?
That's only good if I have the term in front of it.
Okay.
It's when I have a pattern and I go 2, 4, 6, 8, and someone goes, what's the next 3 numbers? Well, I'm not going to use the explicit formula to find it. I'm going to use a recursive and just add 2 because it's much quicker just to do that than to do the whole explicit formula each time. Recursive is good if you have the term in front of the one you're trying to find. Oh yeah, always. We gotta move. We are already way behind. Always moving. Yeah, we're way behind. You lying. It's a good move though. I appreciate it. You're the best student. All right, questions on that? We're good. Go back home, try that out again now that you kind of maybe seen it again. That's what this class takes, right? It's the effort. It's 30 minutes of new homework. It might mean a little bit more of a review from the last night before if you figured something out that you were missing. All right, tonight's homework is actually really nothing new. It's a little bit, but not much new, but the old stuff is gonna kick your butt if you don't know how to graph. So you better know how to graph something absolute value, something in slope form, and something in a little bit of parabolas. I'm not going to expect too much of parabolas because we haven't hit that. We hit that hard in chapter 2. Chapter 2, I will really teach you how to graph parabolas like champions. So here's the thing that's going to happen. What did I tell you a graph is? A visual representation of all the answers. Do you follow me? So the question is, when does y equal x squared? That's the question. And I'm telling you, right here, right here, right here, right here, all these ordered pairs, anything that's on this graph is going to do what to that equation? It's going to make the left side what? Equal to the, so like I'm telling you, if you put a 2 in for x, you'll get a 4 out for y. And that ordered pair would be on this graph over here. Does that make sense? This ordered pair, which is over here, maybe this ordered pair is 10, comma 5. What is 10, comma 5? If I put that in here, I put a 10 in here and equals 5 squared. What is that going to do to that equation? Does 10 equal 25? 10 equals 25, Nick? If it does, let's do business together, buddy. I'll give you $10 all day long. You give me 25 back.
I spent like 5 times.
Does 10
Yeah.
equal 25? That's why this ordered pair is not on the graph, because it doesn't make the equation true. Every one of these ordered pairs would make the left side equal to the right side. Every ordered pair that's off the graph would make the left side not equal to the right side. That's what a graph is. You follow me?
Yeah.
This is 1-5. Yep. You don't have to take notes right now. Right now, I'm just asking you to just learn this comprehension. This is what we're doing. Then we'll actually do it together. This right here is another graph. Yes? Represented by another equation. What do I know about all these ordered pairs? They would make this equation true. Right? What do I know about this ordered pair and this ordered pair? What does that mean? This ordered pair and this ordered pair right here. Those two. 1 and 2. If I put that x and that y into the equation, it would make this one true. And if I put it into this one, it would make this one true. That's the intersection. You follow me? So what happens if this y is equal to this y? This is from geometry. Doesn't that mean that x squared at that one particular point, or 2, would be equaling x plus 5? Do you follow me? If I said a equals 5, and I said b equals 5, what other information can you tell me? A is equal to b. That's the same thing I just did here. If x squared is equal to y, and also x plus 5 is equal to y, then that means that x squared has to be equal to x plus 5. But that only happens when the y's are the same, right? Well, what do I know about this y right here on this graph and this y right here on this graph? They're not the same. That's why that one input doesn't work in both equations. What do I know about the y right here? They're the same, which means that I have the y being the same. Come on. I have the y here being the same and the y being here the same. That means these two things are also equal. Kind of following me? So here's what's going to happen. We're going to be doing, and that's really the new part. That's really Algebra 2. Here's the Algebra 1 that you guys are supposed to be expected coming in knowing that we got to work on. What kind of graph is that? It's an absolute value. It's a V shape. What kind of graph is the right side? A line. Now, do you see how both of these are? We're wanting to know when this is equal to this. Well, one way to solve it is by graphing it. What I'm going to do is I'm going to kind of split them, and I'm going to say, you know what? Let's graph the absolute value of x minus 4 equaling y. And let's graph 1/2 x plus 1 equaling y. And since we want these two things to be equal, we're going to look for their intersection because that's where their y's are the same. Do you understand what I'm just saying right there? So we're going to look for their intersection. So first, let's graph this guy. You see I kind of hyper-focused it on quadrant 1. Why did I do that? Because I already know this is going to move it to the right 4. 1, 2, 3, 4. Which means when I start my X and Y chart, which is how I've told you to graph so far, my first order pair would be 4, 0. Yes or no? What would be the next X I would want to plug in just to see? I don't go to the left. You can't go left. I personally always go right. So I would personally choose 5. It just says all, when I've done it in the past, I just like that side better. You could plug a 3 in and that would be fine. So what does that mean I'm going to plug 5 in for? You gave me the answer. Where am I going to plug 5 into? The X right here, right? This X. 5 minus 4 is 1. Absolute value of 1 is 1. So I get 5, comma 1 out. What would be the next number I would want to plug in? And then I plug in here. 6 minus 4 is 2. Absolute value of 2 is. So 6, 2. Now, since it's an absolute value, what do I know the left side is going to do? It's going to mirror it. Remember me telling you that? So if I went over 1 and up 1, then I'm going to do what? I'm going to go, let's say it like this. If I go right 1 and up 1, what am I going to do? Left 1 and up 1. If I went left or right 2 and up 2, I'm going to go left 2 and up 2. And there's an idea of what that graph looks like so far. Well, you tell me. Is the other one going to be a V shape? It's going to be a line, but what are we going to be looking for? Where those two intersect, and we're going to be looking for the X of the intersection, because we want what X, right? We want what X would make it to where they're both the same number. Well, they're going to have the same Y, they're going to have the same output. We need the X that get out of there. So notice, should that graphing part be anything new? No, it shouldn't. This graphing part that I'm about to do shouldn't be anything new. This is my intercept, 1. I'm going to go up 1 and over 2. Boom, do you already see an intersection? It's actually 2, 2. Does that kind of make sense so far? Then I'm going to keep going up 1 and over 2. Up 1 and over 2. Up 1 and over 2. And I don't have graph paper, but up 1 over 2, there's where they're going to hit the next time. And if I was using graph paper, it'd be easy for me to see that their intersection is at 10, comma 6. So that means my answer is X has to equal what? What could X equal that would make both of them become the same? 2? Or what else? Those are my answers. Now we'll see how smart you are. If I put a 2 in for this X, what would it become? Good. If I put a 2 in for this X, what would it become? And so it would read, when I put the 2 in, it would read 2 equals 2. Yes? What would happen if I put a 10 in? What would the left side become? Nope. Yes. And if I put a 10 in here, what would it become? And it would read 6 equals 6. Because this is the input, and then this is what they would both turn into. Right. Now, what would happen if I put a 0 in? What would happen if I put a 0 in? I don't know what would happen, but I know this would happen. Whatever this turns into would not be the same number as this one. Why? Because they don't intersect. In fact, not only do I know that, I know the one for the V, the absolute value, would be a higher number than the one for the line. Because I can look at the graph and say that output is higher than this output. Try it, watch what happens. You put a 0 in for them, right? 0, absolute minus 4 is -4. That's absolute value is 4, right? And we're saying, does it equal, if I put a 0 in here, 0 times a half is 0, plus 1 is 1. Does 4 equal 1? No. And which one was bigger? The absolute value. Check. I knew all that was going to happen by being able to read this graph and understanding inputs and the outputs and what they mean. And that's what I'm trying to get you guys to understand. Truly know what you're doing when you're graphing. Not just putting dots on a darn graph, but not having any idea. I did it all my life. Put dots on a graph, whoop, whoop, whoop. Had no idea what they meant. Got them right all the time because I could do what my teacher did. No idea what they meant. I don't want that. I want you guys to understand what's going on with input, output, and how that. Like if I pick this point right here, if I pick this x, which we'll call it 1, 2, 3, 4, 5, 6. If I put in for x equals 6, what could you tell me? What could you tell me by looking at the graph? The output of the line will be higher than the output of the absolute value, and they won't be the same number. So the left side will not equal the right side if I put a 6 in for x. And I know that the line's output, this side, would be bigger than this side. Why? Because the y is higher here than the y is higher here. Kind of understanding? All right, what if I gave you this? I'm going to go quick on this one. I'm just showing you weird ones that they can give you. Oh yeah, absolutely. What if you graph something here that's a parabola and you graph a line down here? What does that mean? There's never a time that you'll make the left side equal to the right side. Yep, good question. All right, so again, remember what I told you to do first is we kind of split them and we think of them as their own problem. 3x plus 20 equals y. And then y equals 5. What kind of line is this, or what kind of graph is this going to be? A line. This is still my intercept, so it'd go up 20. This is still my slope, which is -3/1. And I would graph that. I'm not going to keep graphing that. I need you to practice that. That is slope intercept form. I am going to go over this one because this one is one that trips kids up all the time. How the heck do I graph y equals 5? Here's how I do that. How would I get to y being 5? Once you go 1, 2, 3, 4, and then when you go to draw 5, just draw the line. That's how I do it. Does that make sense?
Draw a line.
Draw the line of, because this is, no matter what, guess what happens on this line? Your y is what? No, your y is what every time you're on this line? 5. What? Look over here. I went right, but I went up 5. Doesn't this only care about that I go up 5? Here I went more right, but that's x. I don't care as long as I only go up what? Now, what if I told you graph x equals -1? Then I would just go to -1 on the x, and all I do is draw that line like that. That's the easiest way I feel like to teach that. Okay? Last thing for tonight, if I asked you, which we've kind of already done this one, they're throwing it back in there. What I'm going to do is I'm going to graph x squared minus 4 equaling y. I'm going to graph y equaling 0. And then I want this to be bigger. I want this to be bigger than this. So if I graph that, you should, we know how to do this. This moves it down 4. 1, 2, 3, 4. And then I make an X and Y chart like we've talked about. So my first one would be 0, 4. So if 0, 4 is my first X, what would be the next X I'd plug in?
0, 5.
No. If I plugged in 0, what would be my next X? 1. And then I plug in 1. 1 squared is 1. 1 minus 4 is -3. So 1, -3. Then I'd plug in 2. 2 squared is 4. 4 minus 4 is 0. So there's the right side of my parabola. How do I get the left side? You mirror it, just like we did with the other one. So remember how I went from the vertex to the right one, up one? To mirror it, I would go left one, up one. To get to this point, I went left or right 2, but up 4. To mirror it, I would go left 2 and up 4. And then y equaling 0 is this line right here. And I want to know, when is this graph bigger than that? Well, when is it bigger than that? It's bigger than that right here and right here. So my answer would be, your x has to be less than from here over. So it has to be less than -2. Or from here over would give you bigger. X has to be greater than 2. So that would be my answer. So that's kind of what your homework will ask you to do tonight. A lot of graphing. Make sure we know how to graph, especially the old graph. Joke.